Welcome to MATLAB Simulink Essentials. In this video we will see the simulation for boost converter. For that we will use several components present in the library browser. So this is the circuit diagram for boost converter, and here you can find a switch. So for this switch we can use either a MOSFET or a IGBT. So when this switch is on, at that time current will flow through this closed loop and inductor will store the energy. So during this time the voltage present across this load will be 0, whereas when this switch gets off, at that time this load will receive the energy from the supply voltage as well as from this inductor. So voltage present at this load terminal will be more as compared to the supply voltage. So the name of this converter is the boost converter. So the meaning of this word is nothing but step up. This circuit is also known as step up chopper, and we will do this connections similar to this circuit diagram. So as this boost converter is a DC to DC converter, we will start with DC voltage source. So let us take DC voltage source present in the specialized power system library. We will consider the amplitude of this voltage as 24 volts. Now take the series RLC branch and convert it to inductive type. We will consider all the default values. Now take the MOSFET present in the specialized power system library. Remove the measurement port as it is not required. Now connect this MOSFET across this DC supply. Take a diode present in the specialized power system library. Remove the measurement port of this diode as it is not required. Now I will copy this series RLC branch and convert it into capacitive type. Now take a resistor type of load. So to measure the voltage across this load, we will require a voltage measurement block. Connect this block across this load side. Take a display block to view the output voltage. Connect this display to this voltage measurement block. Now for this MOSFET we need to apply a pulse generator. We need to apply the pulse to this gate terminal. So take a pulse generator block. Open this block. So in case of this period, we can write this as 1 divided by switching frequency. So let us consider the switching frequency as 5000 Hz. We will consider the pulse width as 70%, which denotes that for 70% of the period our switch is on. So now connect this pulse generator block to this MOSFET. Take a power guide block. Change here the simulation type to discrete. Now save the changes, or first of all save our file. Let us take stop time as 5 seconds and now run it. So here our input voltage is 24 volts, and with the help of this boost converter we are getting the voltage at this load terminal as 73.8 volts. So now let us check what happens if we change the pulse width. So let us consider this pulse width as 30% and check what is the output value of the voltage which we get. So save the changes and run the simulation. So here you can observe, as we decrease the pulse width, the output voltage across the load will also get reduced, but still the voltage across this load is boosted. So that's all from this video. Check out the description box for the quiz and do answer them in the comment section. Thank you for watching this video. Like, share and subscribe to the channel Start Scratch, and do check out our other videos to learn similar skills through our bite-sized content.